let's kick this off. This session on clustering and governing ethical AI with 4 different paper presentations. And our first presenter today will be Alejandra Delfino Rosado. She is an IT and health lawyer at INSA. Further, she's an attorney and consultant focusing on data privacy, IT law, health law, public law, and also an associate member of the Asociación Argentina de Derecho Constitucional. And yeah, she will do the first presentation today on a paper about the proposal of an interdisciplinary qualification metrics for AI systems. And so, yeah, we don't want to lose time, so I'll just hand over to you, Alejandra.
Thank you very much. I will just try to share my screen.
Looks good.
That's good. Can you? Okay, perfect. I will just. Okay, well, if you say it correctly, that's perfect. Well, good afternoon, everyone. I am Alejandra Delfin. I am an IT jurist from the Centre d'Epidémiologie et de Recherche en Santé des Populations, which is located in Toulouse, France. And I am going to present you our paper entitled Proposal of an Interdisciplinary Qualification Matrix for AI Systems. But before I begin with my presentation, I would like to thank the organizers for allowing me to present our work during this conference, and thanks a lot, Anna, for the presentation. Well, first of all, I would like to make a quick introduction into the subject. We live in a world where AI is everywhere. Finance, health, education, labor, justice, or police are just a few examples of fields where AI systems are being developed. And thanks to this capacity of AI to quickly analyze data, human actions and decisions are being increasingly supported by these technologies. This represents a benefit because new services and goods can be developed for the benefit of society, such as better healthcare, more effective resource allocation. However, this increasing influence of AI systems on human thinking, interaction, and decision-making poses new risks to human rights and ethical values, such as automation of discrimination, social discrimination or exclusion, social profiling or misinformation, or harm caused by the misuse of personal data. That's why we thought it was necessary to create a tool to evaluate the negative impact of these systems on human rights in order to know the risk and to mitigate them. So we started to think about how we could work on a matrix where we could classify the AI system and better assess its risk. First, we identified the basic points that we wanted to integrate into the matrix, and we agreed that the matrix should have an ethics by design approach and aim at the implementation of legal safeguards. The assessment should be conducted before the use of the system. The matrix should be designed in such a way that it can be used to test methods, data, and results, and that the assessment should aim at the implementation of measures to avoid, reduce, or eliminate risk. In addition, we also concluded that the matrix should also consider that human control, accessibility, transparency and auditability has to be essential for the AI systems assessed, and that the assessment should be conducted on a case-by-case analysis. But as we progress with our analysis, we realize that there is a fragmentation of international legislation for framing AI systems and devices. There is a wide variety of rapidly evolving technologies. That is to say, the technology is evolving so fast that even if regulations or guidelines are published, they are often outdated. There is no universal understanding of concepts underlying AI, such as the concepts of intelligence, intelligent machines, or autonomy. There is an international consensus on the fact that AI should be trustworthy, but at the same time, there are acceptability issues and cultural diversity that make it difficult to achieve. Technical innovation can be rapidly in tension with human rights and ethics values. And last, it is difficult to translate ethical principles into engineering practices. That's what we say to ourselves, that we needed to work on a common interdisciplinary understanding of AI technologies in order to better understand and manage the challenge posed by these AI systems. So what is our response? We have been working for almost 4 years to propose an analysis of existing concepts underlying AI, coming from different disciplines in order to qualify the AI systems based on its risk. Our goal was to provide a tool to measure the risk and benefits of the AI systems to support responsible research and innovation. As you can see, we identified 3 disciplines in order to achieve this conceptual analysis: psychology, cognitive engineering, and ethics and law. We have integrated different theories from psychology and engineering to define what is intelligence and what are intelligent machines. We were based on Cattell, Horn, and Carroll's work, as well as on the Bloom's taxonomy, to define the type of intelligence and the cognitive level that can apply to the system. Then we use cognitive engineering elements to identify the type of learning, that is to say, supervised, semi-supervised, reinforced, or unsupervised, the purpose and scope of the system, is it monotask or multitask, as well as the level of predictability of the system, high, medium, or weak, in order to determine the importance of the human action and oversight during the design and development phases of the AI program or device. And last but not least, we have integrated ethical and legal concepts to identify the main principles for framing AI and to select specific measures in order to address the risk posed by the AI system. For this part of the analysis, we rely on the European fundamental rights and values, and on the European regulations and international guidelines. So the matrix that we propose is composed of several steps, and I will show in this slide the first part of this assessment. First, coming from concepts in human psychology defining intelligence, we can identify general categories: crystallized AI if the system uses learned knowledge and experience and it reproduces equivalent action, or fluid AI if the system has the ability to process, identify patterns, and solve new problems in real time. And cognitive level from level 1 to 6, if the system only keeps unrecognized knowledge, if it can interpret, apply, analyze, or evaluate the knowledge, or if it can create new knowledge. Secondly, coming from the concepts of engineering, we identify the type of technology, the learning method, and the functional scope. And finally, we propose a classification depending on the behavior of the system and its functional purpose. For each of those exercises, we can have alternative or cumulative features. For example, a chatbot can have a crystallized AI, a cognitive level 3 or 4, because it can recognize, interpret, or apply knowledge. It can be a type of technology too, with limited memory. Its learning method can be semi-supervised. It can have a multi-task scope, in the sense that it can implement, inform, and propose options for users. And as a result of this analysis, we will have a qualification output of the program or device. And it is important to highlight that, as it is indicated in red, the more autonomous the device is, the less predictable and the more dangerous it will be. And in a second phase, once we've got the technical qualification, We will assess the ethical values based on, for example, the ethics by design principles that were proposed by the European Commission, which are guiding assessments of this technology. We're going to consider, for instance, the principles of do not harm, the respect of human technology and dignity, and the principles of transparency and justice. Then we will consider a qualification that will serve to legally identify the technology. That is to say, does the law consider that the AI system is a device or device is a good, a person, a sentient good, and is it a hardware, software, or both? And to identify sectoral regulations and quality norms that would apply to the device. As we indicate in the metrics, each technical and legal instrument can also propose relevant evaluation criteria that should be followed. The list that we include in the matrix are not exhaustive. We just mentioned some of the most common. And finally, as an impact assessment output, this exercise will allow us to identify the potential risk of the technology and to implement specific protective measures to minimize the risk and comply with the regulations. And we based this last phase of the matrix on the Trustworthy AI Approach, which establishes that AI should be lawful in the sense that AI should comply with applicable laws and regulations, should be robust both from technical and social perspective, and that AI should be ethical and respectful of ethical principles and values. And before concluding, we wanted to highlight that our conceptual analysis has been performed before the EU or the European Proposal for an Artificial Intelligence Act, which also adopts a risk-based approach and proposes an AI classification associated with the use of these technologies. And this European classification identifies 4 types of risk: unacceptable risk, where the technology would be prohibited; and high, limited, and minimal risk, where the technology can be developed, but it has to respect certain obligations and meet different requirements. And even if the European proposal is not already enacted, it can be interesting to see how both approaches can articulate in the future. To conclude, with this research, we both identified advantages and limits of the matrix. First, in terms of advantages, the matrix offers a conceptualization tool that can be used in any field. It should help understanding AI characteristics and related technological, ethical, and legal challenges by design. It can be the starting point for the design of further risk assessment tools and risk control measures. And it can also be a tool to promote transparency and accountability towards users and the lay public, such as for inspiring AI labeling or products. And last, in terms of limits, we found that the concepts are still developed in disciplinary silos and they are not universal, but relationships between concepts and categories exists, and further specifications would be desirable through additional research and the creations of new assessment tools, such as the document recently published by the World Health Organization, generating evidence for AI-based medical devices. And as we said since the beginning of this presentation, the development of the matrix is still in a theoretical phase, and trials of such matrix will serve to improve it. Thank you very much for your attention, and here is my email if you have any questions or comments.
Yeah, thanks a lot, Alejandra, for this first presentation. Super interesting.
Thank you. Thank you very much.
Totally on point, yeah, in terms of time.
Perfect.
Perfect. Actually, I don't see any question yet in the chat. So when there are coming some, maybe we have some minutes at the end left. But as this is not the case yet, I would just suggest that we move forward towards our second speaker of today, which is Joanna Marcoux. She is an ethical consultant in AI and further an executive board member of the Global AI Ethics Institute in Paris. Further, she's a country advisor for Romania at the International Group of Artificial Intelligence. And she will now present a thesis with a focus on the main principles of an ethical code for companies wishing to implement an AI in their businesses. So, Joanna, stage is yours.
Okay, thank you very much, Anna. So, just a moment, please. I will minimize. Just a moment, please. So I will present you my executive MBA thesis, which are the main principle of an ethical code for company wishing to implement artificial intelligence in their business. And I start just now. Why I have done this study is because the artificial intelligence is a part of our lives today and will be even more in the years to come. The stakes of AI are enormous. Some examples of artificial intelligence are algorithms, chatbot robots, voice assistants, autonomous cars, autonomous weapons, medical diagnostic, expert software, social media, smart cities. How are the specific research questions to be answered in this study? The literature review provides a large number of articles and will be the starting point. After identifying the most suitable ethical theory for the business, the basis of an ethical code will be laid and the main principle will be defined. The primary data generated by the semi-constructed interview will be analyzed. Why this question is important today? Because today in 2021, there is not a code of ethics to regulate the implementation of AI in the companies. There is no law either. What are the objectives of this study, of this research? The main objective of this study is to provide a framework for an ethical code that can be applied in companies that wish to implement AI in their business. The first analysis of the PESTEL analysis, the 6 dilemmas of artificial intelligence are from a politics point of view. AI will bring peace of war. Thanks to AI, it is possible to create robot soldiers. But what if the systems of hackers are hacked by the ill-intentioned organization? From an economics point of view, AI will be layoff or growth. Any discussion involving AI brings us back to the questions of the place of humans in the employment market, if humans will be replaced or not by robots. Society, hell of heaven. From a societal point of view, there are 2 major issues. The first are as AI will create more value for company, everyone will be allowed to benefit from it, or will it create even more inequality? From a technology point of view, AI will be collapse of control. The creation of more and more efficient systems from AI provides solutions to problems that are increasingly difficult and are so complex that humans no longer understand them. And if AI surpasses, are we sure we can keep control? Environment, pollution, or renewable. Each revolution has had an impact on the environment. AI does not escape. The large servers that make a calculation and help machine learning use a lot of energy for their cooling. Legal would be deadlock or innovation. I've seen machine learn from a large amount of data, but this data has been generated in one way or another by humans. So the questions of privacy, is self-evident. Another challenge is that the liability in the situation wherein AI systems make a decision that will create a prejudice. Who is responsible? AI raises, how we can see, the questions, problematics, dilemmas such as safety, explainability, and transparency, fairness, privacy, accountability. Those questions are ethics questions. What ethics are? The business ethics is a philosophical discipline that studies the relationship between morality and human behavior in relation to good and evil. And defining business ethics are business ethics is the rules, standards, code, principle, which provide guidelines for morality, right behavior, and trustfulness in specific situation. To go further, we made to make a decision which theory of ethics seen like a science will be applied to make a framework or code of ethics for intelligence artificial. Ethics of virtue is a theory which originated in ancient Greece, associated with Aristotle. He says that moral conduct is not determined by a universal code, but by the personal traits to make ethically correct decision in the face of a dilemma. Or deontology was founded by Immanuel Kant, an 18th century German Christian philosopher. His ethical principles are categorical imperative that must be followed whatever the circumstances, the context, and the consequences of the decision taken. For example, a lie would be unacceptable even if it would save a life. Or utilitarianism, G.S. Mill's utilitarianism is a form of consequentialist ethical theory that aims to maximizing the group interest. For him, actions are right in proportion as they tend to promote happiness, wrong as they tend to produce the reverse of happiness. I decide at this point to the AI follows the utilitarian principle, and it is the most used theory in the business. For the conception of an ethical code for AI, in the first phase, my work was based on the article, the Ethics of AI, Ethics on Evaluation of Guidelines by Dr. Hagendorf, which compiled 22 major ethical guidelines. We can see it in the first column. The second step was I continued by choosing the article Unified Framework of 5 Principles for AI in Society by Floridi, Mr. Floridi. And after that, I choose 5 articles that with more than 10 principles about each article. I make a total, and I choose to study the first 7 principles, which are fairness, non-discrimination, justice, transparency, openness, safety, cybersecurity, privacy protection and accountability, common good, sustainability, well-being, responsible intensified research funding, human oversight, control, auditing. So after that, I make 4 propositions. The first one are the utilitarian point of view is the of ethics might be the angle of ethical analysis of an ethical code. After that, I will check if these principles are not must be the basis of the implementation on ethical code. Proposition number 3, the responsibility for applying the principle outlined in proposition 2 should be shared between the company that creates the AI system and the company that uses the AI system. Proposition number 4, the principle outlined in proposition 2 should be at the basis of an European regulation for an AI, ethical AI, such as GDPR. The methodology, the research approach was a qualitative data instrument was a qualitative semi-constructor interview. Sampling was a convenience non-probabilistic sampling. The analysis, I used a mixed method for the proposition 1, 2, and 3. I use the hypothesis codic source, and the for proposition, I use the grounded theory approach. I make the cases by academic and operational, by gender, female and male, by culture, mono and biculture. This one are the in vivo nodes matrix. Distribution of nodes for each proposition. I make I encode it and I create the nodes. What can I see is the barrier for the implementation of an IEAI code, a code of ethics in the companies, or the profitability of the company. Another question, important question, is the fact that the human must have the final control. The proposition number one, I thought that the utilitarian point of view would be the better for the ethical code, but the interviewee told me that it will be great that the people which are involved in the elaboration of an ethical code must be deontologists. So we can say that the three theories are linked and should be applied together in business. This validates and completes the research proposition, which is supposed we propose utilitarian as an ethical point of view that should be the basis of an ethical code. The proposition number two, the main principle of an AI code, of an ethical code. After we have the principle that I selected after the literature review with the total in the first column. After that, in order to establish the final table with the main ethical principle, it was required for the respondent of the questionnaire to rank the 7 principles in order of importance according to them. And the first one was given 7 points, the second 6 points, so on. The last one we give 1 point. I made the totals, and what we can conclude is that the principle that I selected in the literature review as validated by the interviewee. Proposition number 3, the responsibility. The autonomy of AI system and decision making should be decided on the basis of the context, usage, and criticability. What the European Council said is the risks. Therefore, for an AI system to make a decision that has an impact on human life, a person, human, must validate the final decision. So any AI system should use a human-centered decision-making approach. I'm not sure that the data generated by the interviewee is not biased due to the function of the interviewee. I decide that it should be the responsibility would be shared between the creator and the client of the AI system. And for proposition 4, AI needs to be regulated. The analysis allowed us to consider that the main barrier for the implementation of an ethical code is the wish to increase the profitability of the company. The sinew of war of AI is the data. Human biases are transmitted to the data and algorithm. Companies do not train the employees in ethics and awareness and AI and the search for solution for an ethical AI. So the core category that led to the grounded theory is AI for human, which implies the key assertion of the proposition. The principle outlined in the proposition 2 should be at the basis of an European regulation for an ethical AI such RGPD. The limitation of this study is that the frame of an ethical code was based in the literature review on accidental articles. Another limitation is the sampling. The recommendation for the company are that it's time to discard our old notions of human versus machine and instead focus on a future of human plus machine. Our recommendation for the company are to create the AI ethics committee within the company to support institutional governments and employees in the fast evolution of technology. New profession could emerge with double competencies, ethical and technical. To ensure that AI is ethical, the European Commission should also consider adopting a law such as RGPD, which can be applied by all member states. These one are the references, and I'm yours if you have any questions. If you want to keep in touch, you can write me at this email address or flash this code, and will you have my LinkedIn profile. Thank you all.
Thank you, Joanna. I think there was one question in the chat regarding the differentiation between proposition 2 and 3, but maybe or regarding to the time, let's first move on, and maybe we have some minutes left in the end, or the person with the question can approach you directly when there are things to discuss. Or I can also forward you the question. Yeah.
Okay. As you want.
Yeah. Okay. Let's first of all stick maybe a bit to the time. Let's see in the end whether we have some.
Okay, great.
Also, in terms of fairness, related to the other speakers. We can move on with our third speaker today. That is Viviana Policena. She's a professor of philosophy, now working for the Catholic University of Córdoba in Argentina. She's further a member of the Global AI Ethics Consortium and also a fellowships evaluation expert at the European Commission. And she will present the digital Kratos Mundi. I'm sure that she will further explain what this is, a proposal for a new global digital governance system. So Viviana, great to have you here, and the stage is yours.
Good afternoon.
Good. We can see you and hear you.
It's okay?
Yes, looks good.
Thanks. Global governance systems, Kratos Mundi Digital. Why imitate nature? 3 manifest group behavior that is they benefit each other and not only feed themselves, but they can keep a fallen companion alive. They are responsible for feeding it through the interconnected root networks under the ground, building smart cities by imitating the geometric pattern of nature means including what is known as the crack of shyness. An unusual and fascinating facts. It is behavior by which 3 take care of each other, thus involving sharing and not competing for life. For 3, producing living is a huge energy cost. So making them grow and collide with the leaves of the 3 next to them is a weight of energy. Nature chooses the best and the law of the stronger. Thus, not always rely in nature show us how life works better if we collaborate. The action of nature corresponds to the initiative of smart cities. They promote collective value with a management approach on the flow of the knowledge. It is a natural collaboration that acquires relevance in a current context of urban and cultural innovation, where borders, as we know them, will disappear. Now we want step further in imitation. Smart cities should be a model of justice. For this, they should train citizens how to dialogue, participate, and deliberate, especially understand the other situation. The technology that define smart city is creativity and decision making. This is derived from optimal communication between the government of the world and citizens. In smart cities, communication is as important as information. This optimizes the quality of public affairs. Smart cities develop a biosphere connected to planet. Smart cities are cities of knowledge, built with new materials and new strategy. The digital governance of each one will have to face structural, social, political transformation, information, and technological problems crossed by the ethical dimension. In smart cities, DNA will be used as a USB. In this way, we can transport and save digital information in the oldest and most efficient data storage system in nature. This storage does not use electricity or require maintenance, nor that it have incompatibility problems. This will transform humanity. The cyber citizens will arrive in which Homo sapiens will be radically transmute this mutation is inevitable. The brain-body network connection will lead us to reality that will be as or more real and physical reality. Nanotechnology will create world. We will lie inside the network and we will transmit thoughts to each other like digital neuronal postcard. Smart cities will be made up of citizens capable of thinking in a network and designing a sustainable environment, and an efficient, ecological, and connected ring architecture. Digitalization is the backbone of smart cities. This backbone require balance to make advantage of opportunities and reduce risk. The balance is sustained by the protection of the fundamental right to innovation, the development of talent, and the protection of public values. Citizens will develop an ecosystem of trust and excellence, and AI will facilitate and regulate the market for data encryption and health. Smart city we include data governance based on digital data, make cloud network infrastructure addressed to quantum computing. All smart cities will develop policies that identify gaps and challenges. They will also address the access, exchanging, and processing of industrial data. The new political system of smart cities is called Kratos Mundi. For me, it is no longer the power of the people, but the power of the world, of the planet. Kratos Mundi is a council made up of representatives of smart cities. Border, as we know, will consequently disappear. Countries as well autonomous and sustainable cities or regions will emerge. New territories that will be represented before the World Council. Although each smart city will be autonomous in its laws and self-sufficient in its production, all will be under the laws of the Council of the World. Kratos Mundi is new structure. Kratos Mundi is a political social organization that attributes the ownership of power of the citizens, in which collective decisions are adopted by each citizen through direct digital participation. Kratos Mundi is a form of coexistence in which members are citizens of the world whose common goals is sustainable development. Kratos Mundi will really on the development of the arts and philosophy. Its education will be based on deep learning in immersive classrooms and laboratories. This will transform the way of teaching and learning. Effective educational system will be developed with augmented reality and mixed reality. Philosophy teaches learning to be human. Hence, the importance of the philosopher as an educator in smart cities. The philosopher as an educator of and integral education along the development of the personality of each citizen can deploy his ethos towards excellence in the acquisition of virtues and values. We should build the ethos together to make it a common ethos. Thus, we can make laws and participate in the res publica. This is the best way to command virtues and happy citizens. Why can philosophy bring to the digital age? Philosophy contributes human dimension, reflection, and ethics. Through philosophy, the challenges and opportunities of the digital transformation of the governance of small cities can be addressed. The governance of the cities will be totally digital, hence the importance of ethics. New humanities emerge. The humanities of data, from which ethical criteria are developed with which to analyze new phenomena from innovate perspective that connect and integrate the humanities with technology in single network. Digital age should be able to anticipate the evolution of the technology and the challenge it will bring in human rights, health, energy use, mobility, data, privacy, algorithm, development, and finance. In the gestation of the new social political structure, Kratos Mundi. For such gestation, collaborative action in which the philosopher, the technological ethicist, and the political ethicist have a fundamental role is of utmost importance. Man-machine coevolution present a specific ethical risk in digital technology and should be monitored to preserve places of human in from machine. Are people ready for a better world? Do people have to have certain spiritual, intellectual, moral, ethical, and other qualities to begin transformation? Citizens should transform our way of competing, or our way of doing politics and economic. We should change educational strategy. We should understand the place we occupy in the cosmos and achieve a moral and reasoning of respect and contribution. There will be no money as we know is today. Knowledge will be the values of each smart city.
Viviana, super sorry to interrupt, but could you come to an end within the next minute, let's say? Sorry.
finite governance in the transparent regulation of the AI ecosystem for efficient decision making in each smart city and global in the interaction of all in the cities that make up the Kratos Mundo. Is in construction, yo creo, the new order global. Sans frontier.
Viviana, you're finished with
Yes.
this? Yeah.
Thanks. Thanks.
Thanks a lot for the talk and the presentation. Yeah, and as there's not a lot of time left, yeah, I would suggest we just go to the next presentation and come from this rather, I would say, global talk. Yeah, we refer to rather global broad topics again to more, I think, yeah, work-related topics. And we come to our last speaker of today. That is Charlotte Unruh. She's a postdoctoral researcher at the Technical University of Munich at the Chair of International Relations. Her areas of specialization are normative ethics and political philosophy. And she's also working at a project of the IEAI, the one on human preference-aware optimization system. And she will now present a paper on designing AI for well-being at work, a three-step approach. So Charlotte, the stage is yours.
Cool, fantastic. I hope you can all see my slides. Yes, perfect. Okay, cool. I'll try to keep this short so that we can have a timely end to this fantastic day of really interesting talks and presentations and inputs. So I'm one part of an interdisciplinary project team at IEAI, and I want to give you a brief impression of the work that I'm doing together with my colleague Charlotte Heid from the Chair of Materials Handling, Material Flow and Logistics, and I think she's in the audience today, and her email address is also here, so you can contact both of us if at the end you have any questions. Right. So I will start with telling you about the initial situation that prompted our research. And we focus specifically on production and logistics processes in industry, and big data and artificial intelligence have, of course, had a massive impact on that sector. So, for example, goods and batches can now often be tracked in real time. So that reveals information about the location of those goods, for example, but sometimes indirectly also about the employee's pace and performance. So, for example, how quickly can people handle things in warehouses? Then there are wearables, there are sensors, there are tags that can collect all kinds of information about goods, but that can also track workers' movements, for example. Material flow can be increasingly automated, which cuts down on repetitive manual work steps, but can also sometimes lead to micromanagement of the remaining manual steps in a workflow. And algorithmic management technologies are increasingly used to kind of steer and optimize workflows, but also to cut costs, to react to competitive pressure that industry faces. And by algorithmic management, algorithmic optimization, I mean here algorithms that can analyze data, that can make predictions, or that can give recommendations for the management of workers. And the example that I will focus on specifically today, and I will go into more detail later, are scheduling algorithms, so algorithms that allocate workers to specific workplaces. Okay, the whole point of this was to say there are new technologies, and these have significant effects on human workers, on the organization and on the structure of their work. And that kind of impact has ethical relevance. However, despite that kind of, I find obvious ethical relevance, optimization technologies and their effects on human workers have not been comprehensively discussed yet from an ethical perspective. Now, interestingly, worker well-being as a center HR paradigm has been rising in importance in recent years. And I think we've seen that during the pandemic, where well-being has risen into even sharper focus, with many workers facing lots of new challenges, such as combining remote working and caregiving and those kind of things. And also the principle of creating beneficial AI is a staple of AI ethics guidelines. So this is not a very new focus in AI ethics in general. However, ethical accounts of algorithmic management and work optimization technologies are still rare. And despite its prominence in AI ethics guidelines, well-being is a value that is seldom comprehensively explored in the debate on embedding ethical values in technology design. So in the next few minutes, I want to tell you about a human-centered framework for the design of algorithmic management technologies that we have developed in our project. And by human-centered, I here mean that the designer puts human well-being in the center of technology development. So human-centered here means focused on the value of well-being at work. Why do we want to have such a framework? The framework adds to the literature on algorithmic management by providing an ethical perspective on these technologies. It also adds to the debate in technology ethics by discussing and proposing specific ways to embed the value of human well-being in workplace technology. And today I will not just give you a very brief overview of the framework. I will actually try to focus on explaining how we are trying in our project to put the framework to use in interdisciplinary collaboration using the case of algorithmic scheduling. And this is where I want to go next. I want to tell you a bit more about the use case that we're working with. And that is scheduling. So to get a better idea of the context that we're concerned with here. So a typical workplace in logistics, you can imagine a warehouse where workers pick goods from shelves, store goods using forklifts, deliver material to a production line, those kinds of tasks. And to reduce boredom and fatigue, to learn about employee abilities, job rotation is very common in those kinds of workplaces. Now, imagine that a warehouse, they might have a certain number of workers available at any given point. And they have a number of workstations that need to be operated or that need to be filled. So how should the company schedule its workers such that enough workers are on a shift to keep all workstations running, but not more, because otherwise the company will be paying workers that don't actually need to be there, right? So that is a simple scheduling problem. And as the number of workstations increases, and also when workers differ in their competencies and their training and their capabilities, scheduling can become pretty difficult pretty quickly. So, not like the easy scheme that I've put on the slide here, it can become really, really complicated. And that is where algorithms come in. So they can be used in these contexts to ensure effective scheduling. So far, this is really nothing new. This is kind of standard practice in that sector. The question that we now want to ask is, how can such scheduling algorithms be designed in a way that also takes the well-being of workers into account? Okay, and here we're back to the framework that I promised I would tell you about. Yeah. So we want to proceed in 3 steps. The first step is to develop a framework of goods or principles that should guide the design of the algorithm. The second step is to specify or revise this theoretical framework in consultation with those affected, in our case, the workers whose shifts we want to schedule. And the third step is to actually design and develop the algorithm. I said that we're interested in aligning our algorithm with the value of human well-being at work. But how should we understand well-being? So I want to suggest that social and political philosophy can actually help us here. In particular, there's an interesting literature on the goods of work that aims to answer the question, what are the goods that work provides us with? What beyond a salary is it that we actually get out of work? And political philosophers Anke Gauss and Lisa Herzog argue that there are 4 goods of work. So excellence, developing and exercising one's skills, social contribution, so contribution to society, for example, by caring for others, community, having relationships with others and doing things together with other people, and social recognition, which can be expressed through status or identity, among others. And the idea is that when employees have these goods, then their well-being is higher, their well-being at work at least. Now, people are very different, right? Some want to develop skills in one area, others in another area. Some like being into contact with lots of different people all day long. Others, prefer working with the same, in a small team maybe. So what the goods of work mean will be different for different people. So that is why in the next step, we want to use this framework to derive preference categories. How do we do that? We talk to people. And in our case, we've done some studies. So we've done small empirical pilot studies where we held short interviews with employees working in a medium-sized company in Germany. And what we found is that people's preferences differ, especially regarding the dimensions of excellence and community, which I put here on the slide for illustration. Yeah, I think I can shorten this a bit. So scheduling systems we think can affect excellence. For example, when some people prefer, as I said, doing very different tasks, and others prefer doing similar tasks over and over again. And I had the other example before, some people prefer working with the same people, generally speaking, and others prefer working with lots of different people. And those were preferences that people also expressed in the interviews that we conducted. Okay, and those are the preferences that we want to actually use to develop a preference-aware scheduling algorithm. So that algorithm will match workers to workstations and give a recommendation to managers. And that final part of the project is something that we, and especially my colleague Charlotte Heid, is currently working on. So the system takes its input from employee preferences and can assign people to different jobs or to similar jobs as they've done before. And when these preferences are taken into account, then our hope is that will increase well-being at work. Okay, I do have a final slide. I wanted to say something about other values, because well-being is obviously not the only value that people should take into account or should be focusing on. So I felt that it was kind of my moral duty as a moral philosopher to emphasize that point and to also say that there are other values, that they are also important, and we should also take them into account. But I think I will not say a lot more about this, just having mentioned it. Well-being is, of course, not everything, even though it is, of course, an important principle, especially, I think, for our use case. Right. I presented a framework for the human-centered design of algorithmic management, illustrated the approach with the example of scheduling algorithms in a logistics context, and together with empirical and technical investigations of our specific context, I think that approach can be used to retrospectively evaluate and improve existing algorithmic management systems, and it can also prospectively guide the development of such systems. Okay, thank you very much for your attention. And if you have any questions, feel free to ask or to contact either myself or my colleague. Yeah, thank you so much.
Thanks, Charlotte, for the talk, the last presentation of the day. Maybe we leave this slide on for one more second. I just wanted to say, I mean, we don't have any more time for discussions, yeah, but I think all the presenters kind of shared their details. Yeah, so in case of any additional questions, yeah, I think everybody can feel free to approach them separately. Yeah, and with this, yeah, I want to thank the 4 presenters of this last session of today. So again, thanks Charlotte, Jana, Alejandra, Viviana. I think yeah, I think we got to learn like 4 very different frameworks, yeah, but in a sense also again related, yeah, to one common topic, which is yeah, AI ethics. And with this, yeah, thanks everybody for the attention, also the guests that we had in this session. And with this, yeah, I can conclude this first day of TRAIF. Yeah, I wish you all a pleasant evening, or depending, yeah, the time that you have right now in the area you're dining in from. But for sure, I wish you additional more interesting talks in the next 2 days to all of us. Yeah. Thanks, everybody. Have a nice rest of the day.